Today then, we're still going to deal with sine, cosine, and tangent. So everything that we do today is still based off of this. SOHCAHTOA. This first example is identical to the ones that we did yesterday. We're simply going to express the ratio as a fraction and then as a decimal rounded to the nearest hundredth. So if they ask me for the sign of P, I'm going to start at P and I'm going to label my parts. What is the 8? Opposite. What is 17? Hypotenuse, which means the 15 is adjacent. Sine. Opposite over hypotenuse. Opposite is 8. The hypotenuse is 17. We should make sure our fraction is simplified, and it is. And then we should express it as a decimal, which would be 0.47. Cosine of P. Adjacent over hypotenuse, which would be 15 over 17. That is simplified, and this one would be 0.88. Tangent of P. Opposite over adjacent, which would be 8 over 15. In decimal form, this would be 0.53. Now they switch to a different angle. So I'm going to do the other angle in a different color. If I'm starting at R and I have to label my parts, what is the 15? It's opposite now. What's the 8? It's adjacent. The 17 is still what? The hypotenuse. That didn't change. The sine of R then. Opposite over hypotenuse. What's opposite? Over 17. Does everybody see that we've seen that before? The sine and cosine are going to flip on the other angle. This is going to be 0.88. What's the cosine of R going to be? It's going to be what the sine of P was. This is going to be 8 over 17. So sine and cosine kind of got flipped around. Tangent also flipped something. What does it do? It's going to be 15 over 8. It's the reciprocal of the other side. And this comes up to 1.88. So everything on this first example is exactly the same as what we did yesterday. Now remember, yesterday we used sine, cosine, and tangent to find a missing side length. Let's take a look at our next examples. You can use trig ratios to find angle measurements, and they're asking me to find angle A. Still based off of this. Remember that when I'm using sine, cosine, or tangent, I always start at an acute angle. They're asking me to find angle A, so where do I want to start? I want to start at angle A. And I want to label my parts. What is the 23? Opposite. What is the 11? Adjacent. What trig function am I going to use that has opposite and adjacent? Tangent. What am I taking the tangent of? I'm taking the tangent of A. And it's going to be equal to the opposite, 23, over the adjacent, 11. Everybody good that far? Now, I want to talk about why we use what we use. So let's just talk about simple algebra things. If I had x plus 2 equals 6, what would I do to solve this? Subtract 2 from both sides. Why would I do that? But why do I do that? Because they're opposites of each other, right? They're inverses. What if it was 2x equals 6? What would I do? Why would I divide? Because they're what? Opposites of each other, right? What if it was x squared equals 9? What would I do? Why would I take the square root? Because they're opposites of each other. If I have the tangent of A equals 23 over 11, and I'm trying to get A by itself, what do I have to do to it? The opposite of what? The tangent. Well, if you look at your calculator, you're going to see something that says tan negative 1. And you're going to notice that it's in what color? Green. It's the second function on that calculator. So we need to know how to key this in. What you're going to key in is you're going to key in 23, divide, 11, equals. Then you're going to hit the button that says second. It's the green button in the left-hand corner. And then you're going to hit tangent. So you're getting that tangent negative 1. And you're going to find out that A is equal to 64 degrees. Notice today we're rounding to the nearest what? Degree. Not to the nearest hundredth, but to the nearest whole unit. If I know A is 64, could I find angle B without having to use sine, cosine, and tangent? How could I find it? Add 90 and 64, subtract it from 180. Everybody okay with the first example?
Wait, how come you're doing it? The tangent from 180?
I said if I wanted to find angle B,
Oh, okay.
I'd add 90 and 64 and subtract from 180, and it would find this angle as well. Okay? Example 3. Where do I want to start? I want to start at A. And I want to label the parts. What is the 18? Opposite. And what is the 27? Hypotenuse. What function do I want to use? The sine. What am I taking the sine of? Taking the sine of A. And it will be equal to the opposite, 18, over 27. By the way, notice I left a little space in here. Did everybody see that? What do you think I left that space for? Because I'm now going to do what? I'm going to take the inverse sine. These are going to cancel out, leaving me just A. This gets keyed into the calculator. So go ahead and key it in and see if you get that for an answer.
I got point percent. Oh, what was the place? 41.8.
I got 41.8.
Okay, but if we round to the nearest degree, next two examples then. Where am I going to start in example 4? I'm going to start at A. And I'm going to label my parts. What's the 3? Adjacent. What's the 15? What function uses adjacent and hypotenuse? Cosine. What am I taking the cosine of? A. And it will be equal to 3 over 15. The opposite of cosine is? Cosine -1, or the inverse cosine. Leaving me A equals. This gets keyed into the calculator. And it should be 78 degrees. Example 5 looks like it might be harder. Why? Because it has square roots in it.
Because the 6 would bump out.
What did you get? What's it say on your calculator?
78.46.
78.46. We need to talk about rounding then. When I'm rounding to the nearest whole number, I only look at the one spot behind the whole number. Here's my question. Example 5 looks harder because you see the square roots in it. But I'm going to tell you, everything is going to be set up the same. In this one, square roots happen to cancel out. If they don't cancel out, leave the square root there. Let the calculator do the work. Where are we going to start? We're going to start at A. We're going to label our parts. Opposite, adjacent. Which function? So, the tangent of A is equal to the opposite, 6 square roots of 2, over 20 square roots of 2. Now, although I could simplify the whole fraction, I certainly would at least cross out what? The square roots. And then I probably would just take the inverse tangent of it. So what I'm going to key into the calculator is right here. And A should come up equal to 17 degrees. Questions on example 5? And we're going to go to example 6. Anytime you see this, where they're asking you to solve the right triangle, what they're asking you to do is find all of the missing pieces, all the missing angles, all the missing sides. So I need to find these three things. I need to find the measure of angle Q. I need to find the measure of angle R. And I also need to find the length of QR. These are the three things that I need to find. Okay? We should be able to find QR before we ever got to sine, cosine, and tangent. How can I find it? Pythagorean theorem. A squared plus B squared equals C squared. 5 squared plus 9 squared equals, and I'm just going to put the QR in there because that's what I'm looking for, QR squared. 5 squared is, 9 squared is, and it's equal to my segment squared, QR. 25 and 81, 106. And the opposite of squaring something is taking its square root. So QR is approximately equal to 10.30 if I round to the nearest hundredth on my side. Everybody okay with that? Mm-hmm.
Could we just put it up there with the radical?
You could, in this case, you could have done this. And it is in simplified form. You could have done that. Or did they? No, they said what? They said round to the nearest hundred. They told me. So I should do this. If they tell me to round, I should round. Now, the missing angles. You have to pick which one you want to find first. Does not matter. So, Bennett, which one do you want to find? Q or R?
Q.
Okay. So, if I'm going to start at Q, I'm going to label my parts. What is the 9? Opposite. What's the 5? Adjacent. And this is the hypotenuse. Why would I want to use the 9 and the 5, the opposite and adjacent, versus this 10.30? It's more than the fact that it's not a decimal. They gave me the 5 and 9. These are exact. The 10.30 is what? It's an estimate. It's close, but it's not exact. So since I want to use opposite and adjacent, which function am I going to use? So the tangent of Q is equal to the opposite, 9, over 5. To get Q by itself, I use that inverse function, giving me Q equals, this gets keyed into the calculator, and you should find out that Q is equal to 61 degrees. Round to the nearest what? Degree if you're talking about the angle. Nearest hundredth if you're talking about the side. Okay? So I found that QR was 10.30. I found that angle Q was 61. How do we want to find angle R?
It equals 180.
I want to take 90 and 61 and add them together. 151. And take 180 and subtract that 151 from it, which means the remaining angle is 29 degrees. You could have used a sine, cosine, or tangent to find it. Guess what it'd still come up to? 29 degrees. Questions?
Could you have found Q first and then use like sine or cosine?
Yes, you could. I can tell you why I used Pythagorean theorem. This 61, is it exact? No, it's rounded. Pythagorean theorem, when I used these two numbers, these original numbers, my number that I came up with didn't use a rounded number to do the calculation. So if I've got a choice of using numbers that they've given me or a number that I had to find that I might have rounded, I'm going to use the original numbers to start with. But it's going to come up, for the sake of argument, it's going to come up to the same thing. Okay? Now, I want to talk about your worksheet because we're going to modify it like we did yesterday. We're going to take a little bit out of it. Numbers 1 and 2, just like we did yesterday where they're asking for the sine of L, cosine of L, tangent of L. We're going to do the first 3, but the ones that they're asking for M, we're going to cross those 3 off that list. We're only going to do 3 for each one of the problems. Okay? And if you flip it over to the back, we are going to skip 16, 17, and 18. Those deal with a different triangle than the 30, 60, 90 or the 45, 45, 90. You can kind of figure them out. If you've got a really good calculator, it'll tell you exactly what they are. Remember that the other ones that are there work off of that concept of the 45, 45, 90-degree triangle, which says if this is 1, and this is the square root of 2, and the concept of the 30, 60, 90-degree triangle, which says that across from the 30, if it's 1, across from the 60 is the square root of 3, and across from the 90 is 2.